All right, some notes at the top. If f prime is positive, what does that tell me about f? It's increasing. In fact, that should be a bidirectional arrow, because if f is increasing, that means f prime is positive. You can use that information either way. And if f prime is negative, what does that mean about f? It's decreasing. Right? Derivative and slope kind of go together. So if the slope is positive, our function is increasing. If the slope is negative, our function is decreasing. That's the first derivative stuff. The second derivative stuff, if the second derivative is positive, I can't do any hand motions with this. If the second derivative is positive, what does that mean about f? Concave up. And if the second derivative is negative, that means f is concave down. Okay, so let's see if we can keep that in mind, and we're going to sketch some graphs based on given information. So let's see. Number one. Actually, let's read the directions first. In 1 through 5, let f of x be a continuous function. Okay, that's good news, right? So that means no jumps, no holes, no asymptotes, nothing crazy. With f of 2 equals negative 1, so it's given me a point, 2, negative 1. Sketch a possible graph given this information about f prime and f double prime. Okay, I like to translate this from f prime information into f information. So you're not going to do this every time you do one of these, but the first couple of times it's probably a good idea. And then maybe we'll hit some really complicated ones later where it might be a good idea to kind of go back to this. So if f prime is positive, Andrew, what does that tell me about f?
It's increasing.
That means f is increasing. Good. Angelina, if f double prime is negative, what does that tell me about f? Concave down. Okay, so now I know that when x is less than 2, my graph will be increasing but concave down. It's like hard to make my arms do that, right? Like increasing but concave down. Increasing, concave down. Something like that. At 2, the f prime is 0. Callie, what does it mean if f prime is 0? It's at the top or at the bottom. We don't really know yet. I mean, we might can figure it out. But there's a horizontal tangent line there. It's a kind of a... I'm just going to put like a horizontal spot. But spot meaning like infinitely small spot. It's a place where it levels off. All right, then let's go over to this last column. Audrey, if f prime is negative, what does that tell me about f? It's decreasing. And Nick, if f double prime is negative, what does that mean?
It's concave down.
Concave down. Okay, so I need to be decreasing and concave down. So decreasing, but concave down. Okay. The point. I should probably start with that. F of 2 is negative 1, so 2, negative 1 is on my graph. And left of 2, I need to increase, be concave down. When I get to 2, I'll be like a little bitty horizontal spot there. And then after that, I'll decrease and concave down. So I guess one thing at a time here. Less than 2, you want to increase and be concave down. Something like that. At 2, we're at a flat spot. And then past 2, we're going to decrease and remain concave down. something like that. And it says possible graph because for this assignment, there's not a whole lot of difference between like how wide or narrow your graph is. All right, why don't you try number 2? You know what? Let's get you set up first, and then we'll let you try number 2. So, Michael, if f prime is positive, then what does that tell me about f? It's increasing. So f is increasing. Alina, if f double prime is negative,
Concave down.
that means f is concave down. All right, Julius, on x greater than 2, if f prime is positive, what does that tell me about f? F is increasing. Macy, if f double prime is positive, what does that tell me about f?
Oh, it's
Concave up. We're still starting at 2, -1. So see if you can piece together what that graph might look like. 2. All right, why don't you try number 3? This time I'm not going to call on people to fill in the bottom row of the table. If you need the bottom row of the table, that's okay. If you want to try to do it without filling out an extra row, that's okay too. I just think it's helpful to force yourself to slow down and think about what does it mean when f prime is negative? What does it mean when f double prime is negative? All right, try number 4. Again, maybe you don't need to be skipping the step. Maybe you need to write out those pieces. What does it mean when f prime is positive and f double prime is positive? It's probably worth your time to write that down and then translate that to the graph. What pieces mean? So f is decreasing, f is concave up, and then maybe even draw a little piece there. So there's your picture for number 4. All right, why don't you try 5 and 6? It's cruising through here. 2, -1. I'm still going to write them down to make sure I don't mess this up. So f is decreasing but concave up. Decreasing and concave up. Just like that. Increasing and also concave up, just like that. So something like a parabola, maybe not exactly a parabola. And then let's pick on people for our table here. Oh, we got plenty of time. We're good. Okay, so Marie, when x is less than 2, what is f prime?
Positive.
Positive, because f is increasing, so f prime is positive. Naomi, how about f double prime when x is less than 2?
Positive.
Why is it positive?
It's concave up.
Because f is concave up. Well, I guess we can still answer this. Leah, how about f prime at x equals 2?
Undefined.
Why is it undefined?
Because there's a constant there.
Perfect. Bailey, how about f double prime at 2?
Undefined.
Why undefined? Do you know?
It's just kind of.
It's kind of weird. If a first derivative is undefined, and you think about the order that you go in from a first derivative, then you take the second derivative. But if you're stuck at the first derivative, I don't know that you're going to get the second derivative. All right, Sophie, when x is greater than 2, what's f prime?
Negative.
Negative. And Jessica, how about the second derivative when x is greater than 2? Also negative. Okay. All good. Turn the page. This type of problem, number 7, is super common on the AP test, super common on the test, like the unit test in here. So we're going to slow down and look carefully at number 7. Let f of 2 equals 3. The graph of the derivative is given. Okay, so the most important thing about this problem is this is not the picture of f. This is the graph of f prime. And most of the time, a test, my test or the AP test, will say it multiple times. Like it says it in the instructions. The graph of the derivative is given. And then on the graph itself, oh look, it's the graph of f prime. And sometimes they'll even label it f prime of x. They don't want you to miss the fact that that picture is not the graph of f, that's the graph of the derivative. That's the most important part of that problem, is knowing what you're looking at. Okay, part A. Determine the intervals where f is increasing and or decreasing. All right, well, f is increasing. How do I know when f is increasing? Like not from this question, but just in general. When is f increasing? When f prime is positive. So let's look at our graph. And our graph is f prime, so I want to know where that graph is positive. So someone look at that graph and tell me the interval where f prime is positive. Okay, the people I'm hearing are right. From -1 to 2, f prime is positive. From -1 to 2, f prime is positive. So that means f is increasing from -1 to 2. Because the f prime is above the x-axis, so those are all positive values. F prime is positive, which means f is increasing. F is decreasing when f prime is negative. F prime is negative there and there. So that would be -infinity up to -1 and 2 to infinity. Because I'm only looking at the sign of f prime. I know, that's the graph is f prime. And so your brain really has a hard time looking at that and saying f prime is negative, f prime is negative. You've got to be careful about what you're looking at. All right, part B. Determine the intervals where f is concave up or concave down. Okay, so forget about this graph right now. How do you know when f is concave up? What would be true? For f to be concave up, f double prime is positive. Okay, that's true, but that's not helpful for this problem because I don't know what f double prime is. Is there a way to rephrase f double prime using f prime? F double prime. How would you find f double prime if you're looking at f prime? Maybe ask it that way. How would you find the second derivative if you're looking at the first derivative? Slope. So f double prime is the same thing as the slope of f prime. So I want to know where the slope of f prime is positive. So the slope of f prime is positive. So now I'm not looking at the values, I'm looking at the slope. So either -2 to 1/2 or -infinity to 1/2. -infinity to 1/2. The slope of f prime is positive. Or you could say, another way to phrase that is, f prime is increasing. Those are all the same thing. But on an answer on a test, I will need you to say something about f prime, because when you're justifying your answers, you've got to justify with the information you've got. And so f double prime is positive is true, but you don't have f double prime, so you have to say something about the stuff that you have. Okay, same type thing for concave down. That would be where f double prime is negative. That would be where f prime is decreasing. F prime is decreasing from 1/2 to infinity. Okay, part C, putting it all together, we want to sketch a graph. And they told me that f of 2 is 3, so there's at least a starting point. Okay, I think I want to almost make a table on the graph, because when x is bigger than 2, I'm not going to write f, I'm just going to say decreasing. From -1 to 2, we're increasing, and less than that, we're decreasing again. So I'm trying to kind of label my graph before I start drawing. And then 1/2, there's a change at 1/2 of concavity. So bigger than 1/2, we are concave down. Less than 1/2, we're concave up. So it looks like there's, I would say, 4 different pieces to this graph. Decreasing concave up, increasing concave up, increasing concave down, decreasing concave down. That's a lot of pieces to go with. Since I have a point over here, I think I'm going to start on the farthest right. Decreasing concave down, that looks like that. So from that spot, I'm going to decrease concave down the rest of the way. Okay, between, I don't know if this is helpful or not. This is not an asymptote. This is me just trying to draw the boundaries of the different spots here. Between 1/2 and 2, I need to be increasing and concave down. Increasing but concave down. Something like that. From -1 to 1/2, I need to be increasing but concave up. Increasing but concave up. A lot of times people will use a little star asterisk type thing to indicate a point of inflection. So that's just sort of a note to yourself that that's where it changed concavity. And then on the far left over here, decreasing concave up. Decreasing concave up. Something like that. Man, that's a tricky problem. There is kind of a check on this, and that is, what type of polynomial does this function look like that we drew? Okay, it does look like a sine, but if it was a polynomial, what type of polynomial would it look like? What power of x would that be? That looks like a cubed. Something, there's other stuff there, but something with an x cubed. What's the derivative of an x cubed? What's the derivative of x cubed? X squared with other stuff. And my derivative graph looks like a parabola. Now, it also looks like maybe this x cubed was negative and this was negative, but so you can sort of check if you understand what graphs and polynomials look like. All right, let's try number 8. Same type question. Maybe it goes a little faster. Given the derivative of f, okay, this picture is f prime. Andrew, what's this picture of? No, I'm just asking you exactly what I just said.
Oh, that's fine.
F prime. Again, that's where people get mixed up. That's the graph of f prime. Determine the intervals where f is decreasing and increasing. And it says justify your answer. If you justify first, I think that's helpful because it tells you what to look for. F is increasing where f prime is positive. F is increasing where f prime is positive. That's true. So, Kinley, on that graph, where is f prime positive?
High School, please put that rally. Philly, band. Steeple officers and senators, mascot and varsity cheerleaders. Thank you so much.
Okay, Kinley said negative infinity to infinity. That's okay and it's accurate. Some people will say negative infinity to 3 and then 3 to infinity. But if you increase to 3 and then you increase after 3, you're increasing the whole way. So that means our graph is always increasing. So where is it decreasing? Where is f prime negative? Nowhere. Okay, goodbye. So this is always increasing graph. I think that actually makes it easier than the first one. Concave up, concave down. F is concave up when f double prime is positive. But Danny, what am I looking for if I want f double prime to be positive? Slope of what? Slope of f prime. Yeah. And so, Danny, where is the slope of f prime positive? Good. 3 to infinity. And then f is concave down when f double prime is negative. But what would I be looking for, Warren, if I want f double prime to be negative, but I've got a graph of f prime? How do I know where f double prime is negative if I've got the graph of f prime?
Slope of f prime.
Good. So I want the slope of f prime to be negative. Or you could phrase it this way. You want f prime to be decreasing. It's another way to phrase that. So, Naomi, where is f prime decreasing? What interval is f prime decreasing on? So it's positive from 3 to infinity. The slope of f prime is positive from 3 to infinity. Negative infinity to 3. Okay, so something's going on at 3. We're increasing the whole way. So my graph is just going up the whole way. But when x is 3, we switch from being concave down to concave up. So I want to be concave down and increasing, and then concave up and increasing. And it didn't tell us a point to start, so it doesn't really matter where that point is. Something like that. Alright, your assignment is the rest of worksheet 4. It's 6 more graphing problems. They're kind of like the first page, but instead of a table format, it just lists things out. And it might be helpful to show your work. Just a crazy thought. How do we get out of here? 10. Let's do number 9 together before we put it away. We got time to do number 9. You already put it away? Well, you can still look and watch. Yeah, Macy? Yeah. Kyler, f prime greater than 0. What's that mean for the graph? What's positive? This is telling me f prime is positive. What does that tell me about f? F is increasing. Okay? F double prime is less than 0. Owen? If f double prime is less than 0, what does that tell me about f? Good, concave down. And then f of 0 equals 2. That's just a point. So I need to sketch a graph that is, and it didn't put any restrictions on that, always increasing and always concave down. So increasing, but concave down. So increasing, but sort of bent down, curved down like that. But you can't ever make like the full turn because it's always increasing. So you read what's given, you interpret it in terms of f, and then you translate to the graph. And usually the best way to go is to start with the points. F of 1 is negative 1. That kind of anchors your graph, and then you can adjust from there. All right. Monday and Tuesday we'll review this, we'll go over the review, and then we'll test on block day next week.